Greetings and welcome back. In the previous section, we learned Puppet node management and how to manage Puppet nodes from the Puppet Master. This section is very exciting as it would really unveil the power of Puppet as a configuration management tool. In this section, we will learn how to use Puppet modules and classes to perform configuration management in an efficient manner. So in this section, we will start by learning what are Puppet classes and how to create them. Next, we will learn how to create and use Puppet modules. Next, we will start to unveil the modularity of Puppet and start learning Puppet namespaces and learn concepts regarding autoloading. After that, we will learn in detail what are Puppet variables and how to use them efficiently in our modules. Once we grasp the concepts of Puppet variables, we will move on to Puppet file templates to learn how to create dynamic files for configurational purposes. Finally, we will learn how to create an external Puppet fact and use it to send custom information to the Puppet master. So let's dive into it and start learning. In this video, we will learn how to use selectors and how to create Puppet classes. So first of all, let's look at a scenario. Let's say you have to install and manage the NTP service on our two Puppet nodes we have created so far. So to install it on our CentOS Puppet node, we have to declare a package and service resource type, and in the title we would type NTPD. However, in our Ubuntu node, we would type the resource title NTP, which is not very efficient. So to cater for this, we use selectors. So let's dive straight into our main manifest file and see how to create selectors to cater for this problem. Okay, so as before, we will go into our main production directory environment and then we will change our main manifest file. So let's go ahead and do that. We would go into our production directory environment via the command cd/etc/puppet/environments and then the production directory environment. In the production directory environment, we would go into the manifests folder and over here we would modify our main manifest file site.pp. So in this file, we will start to write our main selector and the selector name starts with a variable name. It can be any variable name, so we will choose NTP service as the name of the variable. So as discussed earlier, the variable name always starts with a $sign and then the name of the variable NTP service, and we would assign the value as a Puppet fact and the fact would be OS family. The OS family is a built-in Puppet variable called a fact. The OS family fact is actually the name of the operating system family of the respective Puppet node. So after that, we would type in a question mark and then a curly bracket, press enter, 2 spaces, and then we would have an attribute value pair. So the attribute would be Red Hat and its value would be NTPD. So the first attribute tells us if the Puppet node operating system is Red Hat or CentOS, as CentOS is also in the Red Hat operating system family. Then Puppet will set the NTP service variable to NTPD. So this is similar to an if-else statement in normal programming in the sense that this is a simple if-else statement that if the operating system is Red Hat, the NTP service variable would be assigned the value NTPD. So in the next line, we would cater for Debian operating systems and assign the value NTP. And this would ensure that if the operating system of the Puppet node is Debian or Ubuntu, the NTP service variable is assigned the value NTP. So after that, we will assign a default statement or a default attribute and we would assign the value NTP. And the default attribute value pair would describe the case in which neither of these operating systems are found at the Puppet node. So a selector basically takes a set of possible values and assigns the value of the variable based on a condition, and in this example the condition is OS family or the operating system of the Puppet node. So next what we would do is that we would create separate node definitions of our Puppet nodes in the file site.pp. So we would again do a node definition for node1.pack.com and then a curly bracket. Over here we would declare a service type resource and assign it the value or the variable NTP service. 4 spaces and then the attribute value pair ensure running and then enabled set to true. Press enter, close the service type resource declaration and then close the node declaration. After that we would again do a node declaration, and this time we would do a node declaration for node2.pack.com and again 2 spaces a service type resource, the $sign NTP service, which is actually the variable for the selector which we have created above, and then the attribute value pair ensure value would be running and then enabled and value again would be set to true. After that we would again just go ahead, close our service type resource declaration and then finally our node declaration. We would save and exit the main manifest file, and next we would run the Puppet agent on our Puppet nodes to verify if the selector is working. So before running the Puppet agent on our Puppet nodes, we have made a small mistake in our main manifest file site.pp, and instead of the attribute enabled it is actually enable. So we would set this to enable for both node definitions node1.pack.com and node2.pack.com. After that we would go ahead, save and exit, and then we would go into our node1.pack.com and we would run the Puppet agent via the command puppet agent-t, and as you can see the Puppet run compiled successfully and our NTP service is running. And let's go ahead and stop our NTP service and run the Puppet agent again just to verify if the Puppet manifest is doing what we intended to do. So we would stop the service, systemctl stop ntpd, and after that we would again run the Puppet agent. First we would see the status of the ntpd service, and as you can see the service is loaded but it is not running and is currently inactive or dead. We would again run the Puppet agent-t, and now our ntpd service is running. Okay, that is all great up till now, but still our Puppet manifest is very inefficient. This is because we are using the same block of code, namely the service resource declaration, and it is repeating across the node definitions. One of the most fundamental rules of programming is don't repeat yourself, which means to avoid writing repetitive code. So what would be nice would be a way to bunch some resource declarations in a structure. So that's where Puppet classes come in. Puppet classes is a collection of resource declarations, variables, or selectors, or any other Puppet code. You can think of it as a container for resource declarations, variable selectors, or any Puppet code which goes into a node definition. So let's go ahead into our main manifest file and create an SSH class. We would go into our main manifest file site.pp and let's start from scratch. Let's delete everything this file has and create our class SSH. So we would begin our class by typing in the class keyword and then the name of the class, which is SSH, a curly bracket, press enter, and then we would create a selector for the SSH service. So the selector would be SSH service, or the name of the selector would be SSH service, and then we would again use the OS family built-in Puppet fact, a question mark, a curly bracket, 4 spaces, red hat, and the value would be sshd, and this would mean if the OS family variable is returned as Red Hat or the operating system of the Puppet node is Red Hat, the SSH service variable would have the value sshd. Then again 4 spaces Debian, the value of SSH, and this would again mean that if the operating system of the Puppet node is Debian, the OS family fact would return as Debian, and the SSH service variable would be assigned the value SSH, and then we would again give in the default value as SSH. Press enter, close the selector. After that we would declare a package type resource, and in the title we would do an open SSH server, and this name is constant across the Debian operating systems as well as the Red Hat operating systems. So we would give the attribute value pair ensure, and we would set this to installed. Next we would just go ahead, close the resource declaration, and after that we would do a service type resource declaration. Over here we would give the name of our selector SSH service, $SSH service, a colon, press enter, 4 spaces, the attribute value pair ensure, and we would set it to running, and enable, we would set it to true. We have forgot the commas here. A comma, press enter, and then we would close our service type resource declaration, and after that finally we would close our class. So now our node definitions would just contain the class. So let's see how we will make our node definitions. In the node definition, node1.pack.com, curly bracket, and now what we would do is just type in the class, which is SSH, and close the curly bracket. Similarly, for node2.pack.com, we would repeat the same thing, class, and then the name of the class, which is SSH, a colon, a curly bracket to close the class, and then a curly bracket to close the node declaration. So now as you can see, our code is much more structured. What we have done is that we have just created a class in which we have declared all our resource declarations, the package, the service, and also our selector variable. And then what we are doing is just calling the class in our individual node definitions. So let's go ahead, save and exit, and ensure if this manifest is working on our Puppet nodes. And we would do that via running the Puppet agent on our Puppet nodes. So here in our Puppet node, node2.pack.com, we would run the Puppet agent via the command puppet agent -t, and let's observe what happens. So we can see that it installed the open SSH server package, and it also enabled it and started the service. So let's verify this. We would verify this via the command service SSH status. And as you can see, the SSH service is up and running. So believe it or not, that is it for this video. In this video, we learned what are selectors and classes,